Now, as if programming in C++ doesn't get complex enough, we now have another twist thrown in for you, and I want to cover that in this two-part video. And in the first part here, I want to kind of lay the foundation, and then I'll finish it off in part two. But there's a lot to understand in C++, and then when you start to dig into some of the development environments, it gets a little more confusing. Now, when we start to look at Visual C++ 2010, which is the Microsoft Visual Studio development environment for C++, you kind of get another twist added to C++, and it can really create some pretty interesting fights amongst developer types. And so I want to talk about this question of whether you want to use C++ or C++/CLI, or you'll hear it called C++ CLI. But the bottom line is we have really two types of applications that we can build in C++ now. There are those native C++ applications, and then we can do CLR managed C++ applications. Now, if you don't know what either one of these are, just hang on a few minutes and I'll get you up to speed. Now, this whole option about C++, CLI, and all this other stuff became another twist in the plot as of Visual Studio 2005. Because Microsoft in their development world uses something called the .NET Framework. And when you develop using the .NET Framework, it puts certain management environments, if you will, around the code, and it does some things for you. Now, if you've ever developed in C# or VB.NET in that Visual Studio environment, in the .NET Framework environment, you'll notice, wait a minute, I've never had to deal with these kind of choices before, and it's because both C# and VB.NET run as what's called managed code, or CLR managed code. And some of you guys are saying, wait a minute, what exactly is a CLR? Okay, we'll get to that in part two. So for now, let's talk about what is a native C++ application. This is where we open some development environment. It can be Visual C++ 2010, or it can be some non-Microsoft environment for C++. But the bottom line is we're going to write some C++ code. And the C++ code that we write is going to conform to the ISO ANSI standards. It's going to do everything just like the standard says. ISO, by the way, is the International Standards Organization. By the way, if you're a Dilbert reader, they take quite a few stabs at the ISO. But the idea here is that you're going to write the C++ code, and it's going to run natively on a computer. Now, what that means in English is that your code is going to compile to machine-level code, and it's not going to be controlled or managed by any other processes on that computer other than restrictions on the processor and those sorts of things. But by and large, your code's going to run. It's going to have to manage its own memory. It's going to have to manage its own processes, its types, all that sort of thing. It is what's going to have to happen. Now, let's end part one right here, and then let's come back in part two, and we'll talk about kind of the rest of the story.